Okay, week 6, is it? Yeah, week 6. Therefore next week's week 7, and the week after is the break, and the week after is the first prac exam. Feeling confident? No? Well, you've got 3 weeks to get ready for it. 6, 7, break, and most of 8, right? You've got 4 weeks to get ready for it. Okay, let me see. So back to my desktop when it wants to talk to me. Week 6. Oh yeah, good question. Room control, let's see. Don't know. It'll be there soon. Settle. Oh, I've clearly kicked the hornet's nest by mentioning the prac exams. Don't worry. If you understand arrays, the first prac exam is all about arrays. And if you don't understand them, we'll be talking about them a lot more today in the guise of character strings. Alright, a couple of things. A few people are still posting code on the forum, even though we asked you not to. If you've got a question that absolutely requires that you show the code to someone, show your tutor. You could even send them email, but don't post it on a public forum. When you're asking questions, I've seen a couple where it's going to be damn hard for us to work out what's going on. And this kind of ties in with that previous point. Sometimes you really can't work out what the problem is without seeing the code. So you might have to wait till you can show the code to someone. But a lot of the time, telling us what happened, like I ran my program, I tried to read in a number, and then it printed out something totally different from what I typed in. Maybe you didn't use ampersand in the scanf or something like that. So we need more information if we're going to have a chance of diagnosing these kind of problems. It's always tricky to diagnose a computing problem without actually standing there looking at exactly what you did, because often it's not just you, but when people describe what went wrong, they'll leave out some critical details, the things that are going to help us sort out the problem. So make sure you give us as much information as you can when we're trying to debug for you, if you can't work it out yourself. Alright, so I want to take a look at the quiz, because some of the questions were done particularly poorly, i.e. less than half of the class got the right answer. And in fact, in some of them, less than a third of the class got the right answer, which is interesting. Alright, this one here, I thought this was going to be relatively straightforward. What's the answer and why? Who said 3? No, I think that's what a lot of people thought. The trick here, and we obviously write these to be a little bit tricky, is that B is an integer, A is an integer, and when you divide two integers, it uses integer division. Afterwards, the value might be cast into a different type to match the variable being assigned to. But when that expression is evaluated, integer divided by integer, integer division with truncation, so the result of 7 divided by 2 is 3 as an int, and then that'll be cast to 3.0 when it's assigned to res. Okay? So you've got to think about what are the inputs to the expression, not what's the result going to look like. So the expression is calculated and then its value is assigned, possibly with typecasting to a different type. So yeah, I think a lot of people put 3.5 there on the assumption that, well, it's going to be given to a floating point number or a double, and so the result of the calculation is going to be a double, but it's not. It's going to be initially an integer, which is then converted to a double as part of the assignment. Right, this one was done a little bit better. That previous one was done really badly. This one was done a little bit better, but still I think less than half the class got it right. What does this function do? Well, here's a clue down the bottom. One thing to look at, okay, there's clearly a base case here. If the input is 0, then we return the result 0. That's reasonably straightforward. If the input, if the parameter is negative, then what we do is we compute f of the negation of that, okay? So if the input is -3, we compute f of 3. If the input is -5, we compute f of 5. And then we subtract it from 0. So in fact, this case here is really just a way of setting up an f of n on a positive integer. So really the only thing you've got to worry about is positive integers. So if you thought about that, you'd realise, okay, if I get a negative number, I make it positive, I compute f of n of the positive number, and then I negate the whole thing. Alright, so the critical step probably is this one here. And if you pick a small number and try and work out what's going to happen. Alright, so if we ask for f of 3, then n is 3, so we're going to return n of f3 minus 1. In other words, we're going to return 3 plus f of 2. Okay, we need to evaluate f of 2, so we're going to come back into this function. N isn't 0 and it's not less than 0, so the result of f of 2 is 2 plus f of 1. To compute f of 1, we call the function again, and this time n is equal to 1. 1 is not 0, and it's not less than 0, so we go down here again. To compute the result of f of 1, we compute the result 1 plus f of 0. And the call to f of 0, okay, obviously triggers this base case here, so the result of f0 is going to be 0. So the result of doing this is the initial n plus the initial n minus 1 plus n minus 2 plus n minus 3 all the way down to 0. So it's the sum of all the numbers between 0 and the initial value of n. And that also applies to negative numbers as well. It's the sum of all the negative numbers between the original value and 0. So minus 5, minus 4, minus 3, minus 2, minus 1. And so on. So one important thing to notice when doing this, okay, first thing you notice is the base case, n equals 0. As soon as you get 0, you return 0. The next interesting case is this n less than 0, and what's actually happening there is that we're effectively making n positive, and then we're computing an f of a positive n. So really the only computation actually happens on positive values of n, and then that's how you handle positive values of n down to the base case. Any questions on that? Was that a question? Yep.
What if we were to input something like writing down 3 onto?
3 onto?
So if we were to like a
then it wouldn't compile in the first place, so you couldn't ask that. If you wanted to try, I don't think does C automatically typecast floats to ints. You could try typecasting, but I'm not sure that actually works, and I don't think it's automatic. Maybe it is. If it is automatic, then it will probably round it to the nearest integer. So if you put in f of 4.5, it might give you f of 5. I'm not sure. But I suspect what's more likely to happen is a compiler error. So you can't, inappropriate argument type. Any other questions on that? So there's a little bit of reasoning about how the function works that you need to apply to get that out. And if you can't work it out, just try it on a small example. And of course, you can see what's going to happen. If you put in f of 4, it'll be 4 plus 3 plus 2 plus 1, f of 5, da da da. Alright, the fact that it's recursive isn't so interesting. And this one here, I thought we'd hammered scanf to death, and I couldn't understand why so many people got this one wrong. Once again, this was about a third of the class got it right, so 2/3 got it wrong. Alright, so we're doing scanf. We're looking for a decimal integer, and we're going to store the result in the variable x. What the user types is not a decimal integer, and so the scanf is going to fail, if you like, fail to find a decimal integer, and when that happens, it doesn't change the value of x. So x initially hasn't been initialised, so we don't know what its value is. So I think as part of this question, it was x equals question mark was one of the possibilities. So that's what's actually going to happen there. As for the value that scanf returns, we asked it to read one decimal integer. There's only one formatting thing in the format string. It failed to read one decimal integer. It managed to read 0 decimal integers, so that's what the value that it returns, 0. So n is going to end up being equal to 0, and x is going to end up not having its value changed from whatever rubbish was in it initially. So n equals 0 and x equals question mark was the correct choice for that one. Any questions? Yep.
Why is y valid?
Sorry?
Why is y valid?
Oh, I think I had a good point. I don't know. Did that confuse everybody? I think maybe the original question had two variables. And we got rid of one. Anyway, yeah, good point. Blame Andrew. He modified the question after I wrote it. Yeah, so y was irrelevant, but n and x should have been able to give the correct values for those. Okay, well x, we don't know the value because it never got changed by the scanf, even though that was the intention, and n is 0 because there was no digits in the input. Yep. Alright, the reason you might have got that, oh, that's an interesting one. Was that one of the options? No, it wasn't. Alright, that's come about because the initial value that happened to be in x was 0. That's not always going to be the case. You try it on a different machine, or you run it at a different time, you'll get a different result. Okay, potentially that's a little bit tricky. How many people assumed it would be 0? Well, you've learned a lesson. It won't necessarily be 0. It'll just be whatever garbage happens to be in x. Maybe to be less ambiguous, I should have given an initial value to x, like 5 or something. And then the result would, x would still be 5 after executing the scanf. So yeah, in fact, if we'd done that, the final value of x is still 5. It doesn't get changed by the scanf because the input is not a valid decimal integer. Right, so sometimes variables will be initialized with 0, but you would be extremely foolish to rely on that. There's no guarantee what value is going to be the initial value of any variable that you define in your program. So just assume it's a random bit string rather than a bunch of zeros. true. I thought a few people would just type these programs in and execute them and see what came out. All right. Okay, so last time we were talking about C programs, and I described that there were two ways of getting information into a C program, and in fact two ways of getting information out. So two ways to get things in: the standard input stream, which you can use scanf or getchar or fgets or whatever to read information from the standard input. argv are the things that you type on the command line, and that's another way of getting information into the program. Output, you can printf to standard out, or you can fputs to standard out, or you can fputc to standard out. There's another output stream as well that I mentioned called standard error, STD-ERR, which is also available, and typically you meant to write error messages there. Regular output goes to standard out. And by default, standard in is getting info from the keyboard, and standard out goes to the terminal window. You can redirect using less than to redirect the input and greater than to redirect the output. You do that on the command line. argc tells you a number of words on the command line, where I described what a word was before. I'll show you that again in a minute. And argv is an array of strings indicated by char star when we look at the definition of a C main program. And argv is always the name of the command that you executed. So if the command was called a.out, then argv0 would be a.out. If the command was /echo, which we used last time, then the value of argv0 would be /echo. Alright, so let's quickly go back and review that echo program. Alright, so here's typical C main program definition. We've been using int main void so far because we weren't interested in command line arguments, and now we are. So argc tells us how many things appeared on the command line. argv tells us what those things were as an array, which you can see there, of strings. So that's how you meant to read that. argv is an array. What's it an array of? It's an array of char stars, and a char star is effectively a representation for a string. So an array of text strings. So if we run this, and we type 3 command line arguments, all of which are single characters, and it might help if I actually compile it. Then first, argv0 is the name of the command, including the dot and the slash. So I've put double quotes around there just to indicate where the string starts and finishes. The command line arguments, argv1 is A, the single character A, argv2 is the single character B, and so on. We can have more complicated things like, if you put something in quotes, either single quotes or double quotes, it turns into a single word, a single command line argument, and it will be associated with a single element of argv. You can have things that look like ints, but they're not. They're character strings containing 2-digit characters. And the most evil thing is trailing space, because you can't see it unless you explicitly put quotes. Okay, so that thing is treated as a single word because it's enclosed in quotes. 99 is a string consisting of 2-digit characters, and this thing with trailing spaces has those spaces as part of the argv value. And that'll only happen if you put it in quotes. If I type trailing and then space, 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 like this, then see the subtle difference. Okay, the spaces were still there, but they don't end up in argv. Is that a question? Yep.
What if you were to put the backslash n to indicate an escape?
Yeah.
Would it print a new line or would it?
Yeah, it might. Well, that's... So you want to do something like that?
Or just backslash n by itself?
Yeah, right. Let's see. Okay, so it just, the shell leaves it as backslash n. So it goes into the C program as two separate characters. It doesn't go in as a new line character.
I meant without the quotes.
I'll tell you what it's going to be then. It's going to be n, I reckon. Just n. Okay. So the shell, which is this thing that's giving me the prompt and it's reading the command and turning and creating argc and argv effectively, does some interpretation on what you type here. If you put a backslash outside quotes, the shell will interpret that and it'll say, all right, I want to escape the following character. The following character is n. Well, as far as the shell is concerned, an escape n is still an n. So it's different. You get a different effect to what you get if you put backslash n inside a C string. That's interpreted differently because the shell is a different thing to a C program. Don't want to get tied up too much with shell interpretation. You know, there's other things the shell does. If you want to put $100 in, oh, that was echo. That was the real echo. Let's see my echo, what it does. Gives me some weird stuff. Why does it give me that? That's a very interesting question. But what's actually happened there is it's interpreted $1 as something, and somehow it's come up with notified for that, and then the 00. So dollar is a special character for the shell. If you type in a dollar without quoting it, and just to be annoying, if you use double quotes, you still get that. If you want to avoid the dollar being interpreted like it just was, then you've got to put it in single quotes. As I said, don't worry about all this stuff. Why single quotes? Single quotes means interpret the contents of the single quotes one way. Double quotes means interpret them slightly differently. So if you're inside single quotes, do not expand dollars, or don't interpret dollars as anything special. If you're inside double quotes, dollars get interpreted. And one particular dollar that's slightly interesting is $question mark. And we can see that that was 0, and that is actually the return status of the previous execution of the echo command. So this echo up here executed and it did return exit success. Remember that exit success is 0. We return 0 if the command executes all right. And so this is the one place where you can actually see that return value and do something with it if you want to. But let's see what happens. If we try to read a non-existent directory, then hopefully this will be a non-zero value to indicate that there was an exit failure in that cat program because it couldn't find a file that I asked it to print. Okay, so that's, a few people have asked me what happens to when I do return exit success or return exit failure. It goes into the environment that the C program was executed, and you can look at it basically through the shell. If you're executing a program from another program, which you can do, then you'd also see the return status in the program that started the other program. So there are ways that that information can go back into the outside world. All right, in any case, so that's what we're interested in. We've got a command that runs through argv. There are arg, I should have printed out the value of argc, but the value of argc is going to be 1 for that, /echo, A, B, C, D, E, so the value of argc is going to be 6 in this case. So we know that the argv array is size 6, therefore the indices of argv are going to be 0 to 5. Alright, so what can we do with that? Well, one thing that we could do, whoops, we don't want to use VI, we want to go back in here. So last time I got the program simply to add two numbers together. Now I'm going to get it to read in a whole bunch of numbers and add them all up and give me the sum. So let's just make this program. Oh yeah, right, don't worry about that. That's because one of the functions in that library is not complete yet. So, what it was supposed to print was 15, but I think I haven't actually implemented the code yet. I think I just, yeah, good on me. I had pseudocode, so I had it there as a comment, so I didn't actually write the code. Alright, first thing to do, however, so once again, int main, how many command line arguments are there? What are the strings that make up that array of command line arguments? Right, one thing we want to know, one thing we probably want with a program like this is that there are at least two numbers to add up. I mean, you could do it with just one, you could do it with 0 if you return 0 if they didn't bother typing anything. But let's assume that we want at least two numbers on the command line. If that's the case, then argc has to be at least equal to 3. Okay? So the name of the command is argv0. The first number is going to be argv1. The second number is going to be argv2. So argc is equal to 3. So if we don't have enough numbers, or if we don't have enough command line arguments, then we give up. We print a usage message, and you can see what happens. So /add 1, I want to add one number. So it says no, you've got to have at least two numbers. Alright, so let's go back and implement the contents of this. So for each element of argv basically means, and if we're not interested in the command itself, it means start with an index equal to 1, and while we haven't reached the end of the command line arguments, then we want to do stuff. Now this really should have been indented. And to make sure that we go from one command line argument to the next, we can do that. So that's the implementation of, if you like, for each element of argv. So once we've got into the body of the while loop, what we want to do is take the next command line argument, which is a string, possibly a string of digits. We're not going to check this at the moment. We'll just assume that the user types in a string, and we want to convert it to an integer value. And I told you last time that there was a function to do that called A to I, ASCII to integer. And what we want to ASCII to integer is the current command line argument, which is argvi. So we're going to need another variable up here. And then we want to incorporate that into the sum. So that's pretty straightforward, and then move on to the next command line argument. Of course, since we're accumulating a sum, we need to initialize the summation variable to 0. So we don't start from some value that's not part of the sum. Alright, so that's the implementation of all of those components that I initially had just as comments. And of course we need to print the result afterwards. So just going to take the simplest approach, print the value that we've accumulated into sum as an integer. Yep.
What's num?
Sorry?
What's the num?
Num? Oh, thanks. Yeah, good point. Should have been val. I was debating what to call that variable, whether I should call it num or val. I ended up calling it one of each in different parts of the program. The compiler would have picked that up in the complaint, so that would have been useful exercise anyway. Alright, so that's it. So I equals 1 while I less than argc, I equals I plus 1 for each element in argv. Take the current element from argv, argvi, and then convert it to an integer value, store that in the integer variable sum, and then add that into the summation variable. Now, of course, we don't need val, we could just say sum equals sum plus a to I argvi, but I felt like making all of the steps explicit. Alright, so let's write that out. Build add. Now we should get the correct result at the end. Okay, so we iterate, we look at 1, 2, 3, 4, 5. Each of those gets converted to an integer, and then we add them all up. They don't have to be single digit things. You can add 99 and 1, and you'll get 100. The obvious question is what happens if you don't type numbers in? Well, if you only type one piece of rubbish, then you get the usage message. However, if you type 2 pieces of rubbish, then you get 0. And the reason you get 0 is that A to I is a little bit conservative in the way it handles strings, and if the value that you give it isn't something that looks like a sequence of digits, then it just returns 0. Okay? So anything that's not doesn't look like a number just effectively gets ignored. Yep.
If you mix numbers with the letters, what's separate?
Yep. Good question. It depends where you put them. Oops, I didn't mean to do that, I meant that. Okay, so if you do something like that, A to I will look at this thing and see the first item in the string is not a digit, and I'm pretty sure it's going to return 0 straight away. If the first thing it sees in the string is a digit, then it will start converting it to a number. And it will stop as soon as it sees a non-digit. So I reckon what's going to come out of this is 5. So the x4z will be ignored, or it will be converted to 0 because it doesn't recognise it straight away as a number. The 5bc, at least it starts with a digit, and so it'll say, alright, I'll convert that, but I'll ignore the rest. And good. That's what I was expecting. Interesting question. What happens if you put some space? I'm not sure. whether it skips over leading spaces. Let's see. Okay, so it does. So as long as the first non-space character in the ASCII string, that's the argument to A to I, is a digit, then it will start converting it to an integer. Otherwise, it just says, I don't know what this thing is, doesn't look like an integer to me, so I'll just return 0. What else can we try? Anyone got any clever things that they want to see how they're converted? What? What? What are you talking about? Oh! That's what you're talking about. Thank you. That was a D reference. Yeah. Yeah.
Do the quotes, like single or double quotes, they represent like you have different types of characters, like a number or like a dollar sign, different types of characters. You have to use quote notations for that.
No, the quotes really just tell you where the boundary of our word is. They don't signify anything in particular. I mean, I could write this one with single quotes, and I could put that one in double quotes, and get the same result. And I could have trailing spaces as well. So it keeps reading. Once it sees the first digit, it keeps reading until it sees something that's not a digit, and then it stops. It assumes that's the end of the number. So whether it's the end of the word, or whether it's some other piece of rubbish that you put in, doesn't matter. Both of these characters, exclamation mark and question mark, are also special to the shell, so I'm not sure what's going to happen here. Okay, luckily it just ignored them. Yep.
You always have to define RC and RB as like an instant character.
Yeah. Some people actually define argv like this. Whoa. Just to throw a bit of confusion into the ring. So sometimes you'll see it defined like that. And if you think about it, that's kind of makes sense. Because remember, I think I said last time that if you've got an array, the array is effective, or the name of the array is effectively a pointer to the first element in the array. So another way of viewing this array of strings is a pointer to the first element. The first element is a pointer. So if I say char star star, it kind of means the same thing as what's written here. But I think this is probably more meaningful at this stage. Leave it. So an array of strings, and the strings are determined by the shell as it's passing the command line. All right. Anything else on that? Now?
Yeah, how would you determine if I entered numbers unworthy or if I entered the letter as well? How would I check that?
Oh, okay. A to I can't. If you really want to, you have to resort to a variant of scanf that can read from string. So maybe I'll show you that. So normally scanf will read from its standard input. If you want to read from a string, or you want to try and parse a string, you can do it like this. So this will have similar behaviour to what we just looked at. Okay, so we know what scanf does. scanf does the same thing, except it does it from a text string. Okay, so take this text string argvi, try and interpret it as a decimal integer, and if you can, store the result in the variable val and return 1. Okay, the number of %Ds that you managed to accomplish. If the thing that you're looking at isn't a number, then scanf will return 0. So this version here is just going to ignore anything that's not recognisable immediately as a number, which is what we were just doing. So let's go back. Hopefully, if I run some of these, it should behave exactly the same as before. You might argue, hey, how do I know it's a different program? Well, I just recompiled it. You can see the recompilation there. So you'll have to believe that it's a new thing. So that variant of add kind of checks as well as reading a number. And if you really wanted to complain, then you've got the capability of doing that. So you could say if it equals 0, then we write a rude message and we give up. So if the thing that I just tried to scanf didn't look like a number, then I can do something like this, abandon the rest of the program. Otherwise, I've got a valid number, and then I can do something with it. I can add it into the sum. So remember, scanf, question 5. Scanf attempts to read from somewhere, in this case it happens to be reading from a string, and interpret that stuff that it's reading as a decimal integer. If it can, it will store it in this variable. If it can't interpret it as a decimal integer, it will return the value 0 and leave val unchanged. Okay? And so the value that what scanf will return is 0. So that tells us argvi didn't contain anything that looked like a number. So let's have a look at how that's different. Oh yeah, silly John. fprintf requires you to supply a file. Maybe I'll just do printf, it's simpler. Right, so printf. Okay, that's still working correctly. And then that'll stop as soon as it finds something that doesn't look like a number and tell you what that thing is and the fact that it's not a number. So one thing to notice about this, as soon as you find something that's not a number, it just stops. It doesn't look at any more of the command line arguments. Neither does it print out the sum that it's accumulated so far. So it's kind of assuming if there's something that's not a number, the whole thing's stuffed up, so I'm not going to keep going. If I wanted to, I could have printed out what the current value of sum was at this point, and it would have been 6. But we decided the way we're going to handle this error is just to give up. We could potentially something like this. And then it would tell me that it added those first three things. If I was to do something like 1 followed by something that's not a number, followed by something that is a number, then it's going to read the first command line argument 1, convert that to a number, incorporate it into the sum. It'll look at the next command line argument, which is A, and say, nope, that's not a number, and so I'm going to give up. But what I've accumulated so far is 1. Alright, so I guess the interesting thing about this is this variant on scanf, and in fact, I would argue that the most commonly used variant of scanf is this one. If a C programmer wants to try and parse input, what they're likely to do is use an fget, read the next line into a buffer, and then try and use scanf to parse that line. So scanf is probably something that you'll see. Any other questions on that? Good. All right. Let me see. What was the next thing? Right, I wanted two things I wanted to do before we finish today. One is take a look at implementing string manipulation functions. So we've already seen that there are things like string compare, string copy and so on. I want to see how they actually work inside by implementing them, and also start talking about file manipulation. So how do you get stuff from files or put stuff into files apart from file redirection. But before doing that, I wanted to talk about a couple of C idioms. So far, we've been writing that all the time. I is assigned I+1. Nobody writes that. They all write that. Okay, I++. So that's much shorter. I'm sure if you looked at any C books, you would have seen that. So you can use that instead of I equals I+1 to save a bit of typing. Always a useful thing to do in prac exams. As long as you treat this as a statement like this, everything's fine. You can write it as I++. You can even write it as the other version, ++I. So as long as you write them as a statement, that's going to work fine. As soon as you start sticking these things into expressions, then you have issues. Or as arguments to functions. So don't do that. Just use them as statements. The difference is that this uses the value of I, and we're not actually using it because we're just doing this as a statement, and then increments the value of I, adds 1 to it. This version increments the value of I and then uses it. Well, we're not using it for anything, so both of them increment the value of I and don't use the modified value in any way. So the overall effect is the same. They both increment the value of I, so it's the same as doing that. So I think maybe I'll write I equals I++, I equals I+1 a few more times, but from now on I'll start doing I++ because it's shorter to type. Another idiom that C programmers use, they don't write loops like that, even though we have been, you know. I equals 0 or I less than argc, blah blah blah, argbi, and then I equals I plus 1. This kind of pattern is so common in C programs that there's another syntax for doing it, which is the for loop. And I'm sure a lot of you have seen for loops before. I don't know whether the style guide is going to prohibit for loops. Who cares? And of course, writing I equals I plus 1, we've already seen a shorter way of doing that, which is I plus plus. So this is a way of iterating from 0 to n without having to write, 4 lines of code. So you can do it in a single line. Works fine as long as you're doing relatively simple iterations. So I might even start using that. In fact, let's take a look at add.c and recast that using what we just saw. So the way I can do that, I starts at 1, doesn't have to start at 0. It's whatever you want us to start at, and I plus plus. So we could get rid of that. And we can get rid of that. And that makes the code shorter, which we always like. Makes it a couple of lines shorter. The nice thing about the for loop is that it packages the stuff about the iterations in a single place, so it's easy to see what kind of iteration is happening. And I guess I should have said that the for loop has 3 bits. It has an initialization bit, where you set some initial value. Most of the time a for loop is used just for a single variable to iterate over a range of values. So you're setting the initial value of that variable, then you've got the condition under which the for loop should continue. So as long as I is less than arg c, keep going, and then you've got the final bit is the increment bit. How do I go to the next iteration of the loop? Or what should happen before I do the next iteration of the loop. So together, very nice, very simple mechanism that allows you to write your programs a little bit more compactly. And let's just prove that it actually works. That was the add. So that's going to iterate over all those things and add them up. And I guess I should have used a set of numbers that we knew the answer for. So that's working. And it's going to behave the same if we put non-digits. So it'll tell us what the sum was that we reached so far before we hit a non-number. Well, let me think. There is, it's 12 o'clock. All right, I'll stop there, and then after the break we can talk about string manipulation and file manipulation.